In this video, we're going to apply what we learned in the previous video on functions to real-life situations, so that's why it's called applications of functions. So your two objectives, after watching this video, you should be able, that you can write a function rule for a given situation, and you can state the domain and range for a given situation. So we're going to look at two separate situations. In each situation, you're going to write a function rule, which is an equation with two variables. You're going to state what the domain is, your input, or the independent variable, and the range, your output, what are all the possible outputs in that situation, or it's the dependent variable. So our first situation is each shirt costs $15. Write a function rule on the amount of money spent. So to do a function rule, we need, it says, two variables. So you have to look at what we can change in this situation. Well, the first thing, if each shirt costs $15, you can change the amount of shirts you buy. So one variable is your shirts. So a good letter for that, or variable, would be S. And you can pick any letter, it doesn't matter. I generally like to pick variables that match what it's talking about to help keep things straight. And then every time you buy something, you have the amount of money you spend. So if you bought two shirts, it would cost you $30. So you can go M, and that would be your money spent. Alright, so you have your two variables, and now we just need to write the equation of how these two work out. Well, if each shirt costs $15, and I want to know the total money spent, my equation would be the amount of money I spent would be 15 S. So if I bought 3 shirts, I take 3 times 15, and that's how much money I owe. So the domain is input or independent variable. Remember, this is the one in charge. So in the situation, we have two variables. We have the amount of shirts we buy and the money spent. Well, who really controls the situation? Well, that would be the amount of shirts you buy. The more shirts you buy, the more money you spend. So we need to look at what we can have for values for S. So S is our, for our domain, and then M is our Y. So really looking at the situation, S, what values for S can we have? Well, can we have negative numbers? Or another way to think of it is, what's the lowest number you can have for S? Well, you can buy 0 shirts. Okay. And then, what is the highest amount you can buy? Well, if you really think about it, is there a limit of how many shirts you can buy? If you really think of the contest, yes, how many are actually at the store. But if you really took that out of play, it can go up to any amount. You cannot have negative numbers, because negative numbers, you can't buy negative number of shirts. So my domain would be S is greater than or equal to 0. I can buy 0 shirts or anything higher than 0. So my range is the amount of money I can spend. So again, think of the lowest amount you can spend. Well, you have the choice. When you buy 0 shirts, you will spend $0. And then the more shirts you buy, so what is the highest amount I'm going to spend? Well, since we don't have a limit on the number of shirts, we have no idea of how much money I can spend. I can spend thousands or millions of dollars if my number of shirts are unlimited. So my M is greater than or equal to 0. I can't spend negative money. They're not going to take money away for not buying anything. And then I am unlimited. I don't have a top cap. Alright, so let's look at our second situation, our last situation. You have $30 in your lunch account, and each meal costs $1.25. So again, we're going to write a function rule for the money left in the account. So we need our two variables. And then we can write our function rule, our equation. So our two variables. So what can change? Well, we have the money left in the account. So I can go M, and that is money left. And then what's going to determine how much money is left? Well, that's how many meals you bought. Well, notice I can't use M again, so we're just going to go F for food in my head. But you could have picked a different variable. You could go X and Y if you love X and Y. And that is the number of meals. $1.25 meals. Alright, so now we need to write a function rule. So who is your variable in charge? Who is your independent variable? Well, that would be F. That is your independent variable. So F is going to be our domain. And then M is our range, what we're going to get out. So let's think about here. I'm writing for how much money I have left. So M, if I was trying to calculate how much money I have left, I know I have $30. So I have $30. Now, would that go up or down based off if I bought meals? So if you think of your lunch account, every time you buy meals, the school does not give you $1.25. They take away $1.25. And then that is per meal, and remember, per refers to multiplication. F. You could write this one as negative $1.25 F plus 30 equals M. I do not care which way you write. Alright, so now we have our function rule, so now we need to write our domain. What are all the values of F I can have? Well, what is the lowest value you can have? So the lowest amount of meals you can buy. Well, you can choose not to eat lunch, which would be 0 meals. You wouldn't have negative meals. You can't eat a negative amount of meals. And then what is the highest? Well, on this one, we do have a limit because I only have $30 in my account, and each meal costs $1.25. So once I spend the $30, the school can refuse to give me the meals. So I need to figure out how many meals I can total have. And the easiest way to do that is take 30 divided by $1.25. How many $1.25 meals can I have? So dividing that out, that gives me 24 meals. Alright. So if I'm writing my domain, now I'm in between. I have a lowest and I have a highest. So I can write an inequality for this. Here's F. I can go higher than 0, or I can choose to equal 0. And I can go lower than 24. I can't go higher than 24, but I can have 24 meals, and then my amount would be 0. So what is my range? What's the lowest amount I can have in my account, and what is the highest? Well, since it's going down, the lowest amount I can have is $0. We're assuming that the school is not going to let me have a negative balance. And then what is my highest amount? My highest amount will be what I started with 30. So again, I can write an inequality. 30, this is my lowest. I can have $0 in my account, and I can have 30. So that's why it is equal to. So just to review, again, we're writing a function rule, how two variables relate to the situation. You're writing an equation. And then that just kind of helps you plug in numbers to figure it out. You have your domain, which is your independent, or your input, or your independent variable. And you really got to think about high and low. So low to your high. And that kind of tells you what you can put in your domain, what's the lowest number you can put in, what's the highest. And the same as range, which is output. What is the lowest output you can have, and what is the highest. Just a reminder to do a reflection so you get credit for watching this video.